லிங்க் எல்லாருமே யூடியூப் லிங்க்ல இருந்து வாங்க.
Sir. Sir.
பிரின்சிபல் சார் கெஸ்ட் வந்து ஒரு 10:55 கா ஜாயின் பண்ணிடுறேன்னு சொன்னாங்க சார்.
ஓகே மேடம், ஓகே வர.
சார் ஸ்ட்ரீம் ஆகுது. ஆடியோ சார்.
பிரின்சிபல் சார் கெஸ்ட் வந்து ஒரு 10:55 கா ஜாயின் பண்ணிடுறேன்னு சொன்னாங்க சார்.
ஓகே மேடம், ஓகே.
சார் ஸ்ட்ரீம் ஆகுது.
Okay, madam. My voice is audible, madam?
Audio. Sir.
Regine Pastor.
Yes, yeah.
Okay, okay. Good morning, good morning. Okay, thank you.
Regine sir, யாரோ வந்து யூடியூபும் ஜூமும் சேர்ந்து ஓபன் பண்ணிருக்காங்க. சோ எக்கோ அடிக்குது. ஒருத்தர் க்ளோஸ் பண்ணா அது ஓகே.
வாய்ஸ் வருது இல்லையா? சார் நானும் பண்ணிருக்கேன். இல்லாமா போ பண்ணிக்கிறேன். மேம்
எஸ் சார்.
இப்போ நான் யூடியூப் க்ளோஸ் பண்ணிட்டேன்.
உங்க வாய்ஸ் பிரேக் ஆகுதுங்க சார்.
ஓகே மேம், நான் ஜாயின் பண்ணிட்டாங்க மேம்.
எஸ் சார். குட் மார்னிங் சார், பாலசுந்தரம் சார். பாலசுந்தரம் சார்.
சார் வரல என்ன மேடம்? சார் லிங்க்ல வந்துட்டாங்களா?
வந்துட்டாங்க சார், வந்துட்டாங்க சார்.
மியூட்ல இருக்காரா மேம்?
எஸ் சார்.
பாலசுந்தரம் சார். சார் ஜாயின் பண்ணிட்டாங்க சார். ஆனா
ஆடியோ
மைக் கனெக்ட் பண்ணல மேம் அவரு சார் ஆடியோ.
சாரோட மைக் கனெக்ட் பண்ணல மேம். இல்ல மைக் கனெக்ட் பண்ணல சாருக்கு என்னன்னு தெரியல.
இல்ல ஒரு ஆடியோ கனெக்ட் ஆகவே இல்ல சாரோடது.
சிம்பிள் இல்ல பாருங்க மேம்.
சார் நீங்க ஜாயின் பண்ணிட்டீங்க. ஆடியோ நான் பேசுறது ஆடிபிளா இல்லைங்களா சார்? அப்படிங்களா சார்? இல்ல அப்ப நெட் ப்ராப்ளம்ங்களா? ஓகே. பட் நீங்க இங்க வந்துட்டீங்க, உள்ளார பார்ட்டிசிபென்ட்ஸ் லிஸ்ட்ல இருக்கீங்க சார். பட் யுவர் ஆடியோ இஸ் நாட் எனேபிள்டுன்னு நினைக்கிறீங்க சார். அப்படிங்களா சார்? திருப்பி டிஸ்கனெக்ட் பண்ணிட்டு பண்ணுங்களேன் சார் கொஞ்சம். பண்ணுங்க சார். ரஜின் சார் அவருக்கு கனெக்டிங்னு சொல்லிட்டு அப்படியே ஸ்கிரீன் வந்து அப்படியே இருக்குன்னு சொல்றாங்க சார். இப்ப கனெக்ட் ஆயிட்டாங்க சார். குட் மார்னிங் சார்.
சாருக்கு வந்து அந்த ஆடியோ சிம்பிளே காட்டல மேம்.
கனெக்ட் ஆயிட்டீங்களா சார்? அப்படிங்களா சார்? நான் இப்ப ஒரு லிங்க் அனுப்பி விடுங்களா சார்?
சார் உள்ள வச்சார் மேடம். வீடியோ தெரியும். குட் மார்னிங் சார்.
குட் மார்னிங். குட் மார்னிங்
டாக்டர் பாலசுந்தரம், டாக்டர் பிரின்சிபல் ஆஃப் RMKCVT சார்.
சார்
குட் மார்னிங் சார். குட் மார்னிங் சார்.
குட் மார்னிங்.
Trichy sir.
Morning, sir.
Yes. How are you?
Fine sir. How about you sir?
Fine.
Thank you sir. Thank you for coming and accepting our invitation sir.
Thank you.
WhatsApp.
Josephine ma'am, shall we start sir?
Yes
Principal,
madam.
sir?
Yes madam.
Yes sir.
Ma'am,
Josephine ma'am start பண்ணிடுங்க.
okay, ma'am. Yes, sir. Respected principals, sir.
This meeting is being recorded.
Ma'am, start பண்ணிடுறேன் ma'am. Respected principal, sir, dean sir, guest of honor of today's event, beloved heads of the department, professors, faculty members, and my dear students, a very pleasant and cheerful morning to one and all present here. In this auspicious day, we have a tech talk on what and why of data interpretation in data science application. Now, I invite our principal, Dr. K. Rama, who is the guiding light of our institution, to welcome the virtual gathering on Zoom. Sir, please,
Okay.
sir.
Okay, thank you, madam. Most respected chief guest at today's program, Dr. S. Balasundaram, Professor, Department of Computer Application, National Institute of Technology, Trichy.
Thank you, sir.
HOD of AIDS of our college, Dr. Prusha Lakshmi, HOD of CHE, Dr. Valarmadhi, Dr. Vijay Raja, Dr. Rajin Bal, the other coordinators of this program, participants from our group of institutions, both faculty members and my dear students, very good morning to all of you. At the outset, I would like to thank the organizers of this technical talk for giving this opportunity to deliver the welcome address. First and foremost, on behalf of our department, especially on behalf of our chairman and vice chairman, and on behalf of the entire faculty members and student community and RMK group of institutions, I welcome today's expert and the chief guest, that is Balasundaram, professor of NIT Trichy, for accepting an invitation and being a resource person with us to deliver the talk on what and why of data interpretation in data science application. Welcome you, sir. On behalf of management, welcome all our RM group of family members, welcome you, sir. Next, I welcome the person behind this technical talk, Dr. Prusha Lakshmi and Dr. Valarmadi, HODs of AIDS and CSC department of our college. Welcome, madams, Dr. Prusha Lakshmi and Dr. Valarmadi. And I also welcome the coordinators, Dr. Vijayaraja and Regine Paul, for arranging this program in a grand manner. Welcome, Dr. Vijayaraja and Regine Paul. I welcome all the participants, both faculty members and students of our group of institutions for this program. I welcome you all. So once again, I thank the chief guest and the resource person, Dr. Balasundaram, for accepting an invitation, being a resource person with us. Welcome you all. Welcome. Thanks for giving opportunity.
Thank you.
Thank you, sir. Next, I would like to invite Dr. Pradusha Lakshmi, Professor and Head of the Department of Artificial Intelligence and Data Science, who always encourages teamwork and fosters collaborative environment, to introduce our esteemed guest. Please, ma'am.
Thank you, ma'am. Respected principal, sir, today's guest of speaker, Dr. S.R. Balasundaram, sir, faculty members, students, friends. Good morning to one and all present here. It is an immense pleasure to introduce today's guest of speaker, Dr. S.R. Balasundaram. Dr. S.R. Balasundaram has been working since 1987 at the National Institute of Technology, formerly known as Regional Engineering College, Tiruchirappalli. After completing his MCA from PSG College of Technology, Coimbatore, he joined REC Trichy during 1987 as a computer programmer. He completed ME in Computer Science and Engineering during 1992. Currently, he is working as a professor in the Department of Computer Applications. He earned his doctorate in e-learning and assessment from NIT Trichy and has more than 80 papers in reputed journals and proceedings of international conferences. His areas of interest are web and mobile technologies, cognitive sciences, and e-learning technologies, and delivered more than 80 invited talks. He authored a book, co-author for 4 book chapters, and edited 2 books. He is presently guiding number of PhDs and he has guided 9 PhDs. He was associated with the computerization of national level admission process for common MTech counseling during 2010 and 2013. As head of computer support group during 2012 and 2015, was involved in the planning and implementation of Wi-Fi for hostels. He held the post of Associate Dean R&C and involved in the activities related to Teaching and Learning Center and Digital India during 2015 and 17. He is a coordinator for Akash project of IIT Bombay under NMEICET of MHRD. He has conducted workshops, internship programs, and procured equipments to set up Akash Project Lab. Also involved in setting a lab on e-learning and HCI. He is a member Center for Entrepreneurship Development and Incubation under aegis of Ministry of Communication and Information Technology, Government of India. He was the co-PI for the project Full Duplex and Cognitive India Radio Architectures for Spectrally Efficient Communication, sponsored by UGC UK India Education and Research Initiative. Currently, he is associated with the project CEDI for implementation on-off scheme, expansion of technology incubation and development of entrepreneurs in the areas of electronics and ICT, funded by CEDI under DATI MHRD. It is a great honor to have such an eminent person today with us as a guest of speaker for this technical talk. Thank you, sir, for accepting our invitation. Now I hand over the session to Dr. S.R. Balasundaram, sir. Please, sir.
Thank you, madam. So we'll share. Is it visible?
Yes, sir. Yes, sir.
So, first of all, my sincere thanks to the entire organization, the committee members, and Dr. Pratyusha for inviting me to be part of this activity. So I thank for the initiative for this kind of topics because as you all of us know that currently the entire globe is moving around data science. So data science is a very vast subject, but what are things to be seen in that? As everything moves around data, many of us have to take care of, rather we have missed to spend time on interpreting data and analyzing the data. So in that aspect, this talk is more towards the interpretation of data, its importance, but it has got a very long presentation. Though the presentation contents may be long, I will try to shorten. Wherever possible, I will skip the slides. So first we will see what is data science. I am not moving the slide now. I am just giving an intro. First we will see about data science. What is the workflow? What are the applications? And then why data interpretation is important, the types of analysis we can have, and based on that interpretations can be thought of, and then moving to a case study followed by some important observations to be taken care as a data scientist. This is what we are going to cover for this entire session. Suppose we are asked in an examination, define data science, part A, a 2 marks question, we can simply write, it is a field that aims to convert data into information, supporting decision-making process. Very vital and useful definition. That's good. 2 marks given. But from curriculum to practice, what are the things to be taken care? So in that case, we have to explore on this topic on data science. So based on this wonderful article, I have referred many articles for this. So the credits go to such internet sources and great people. And I am also joining with them to highlight their features. Actually, if we see that our astronomy is one of the greatest topics that involve data, complexities, interpretations, then finally predictions also. If you see, as an example, Kepler, who dealt with the data, planets data, which are already collected by Tycho Brahe for the sake of Copernicus theory, we have a doubt whether he is the first data scientist. If Tycho Brahe has um, initiated it, he is a data scientist. Or if Copernicus, so like that, it is very difficult to find the root for who is the first data scientist. But each and every stage, somebody or something has helped to achieve this state. There is a good summary on, we can think of 4 generations of this data science. If we think this as a research paradigm, there are different paradigms. The first paradigm, empirical science, just describing the natural phenomena. See, people have studied the movement of birds, people have studied the migration of people, then ethnic sciences. So all these things, they're all based on empirical science. And slowly they move to theoretical paradigm where they can suggest some models. See, the credit goes to social science, humanities, and medical people for involving these kind of theoretical paradigms. There are a lot of models will be suggested, and we'll try to experiment with the models, check whether it is correct or not in my scenario also. Then, certain decades ago, we had the computational paradigm where we can get clarity, where scientists simulate complex phenomena using algorithms and computers. Only after algorithms and computers came into the system, we are able to get some idea about that, why it happened, what will happen, like that. But more specifically, according to Gray, who focus on data exploration, he focused on data capturing, simulation, and then analysis as well as inference have to be done. So this holds as a better definition for data science. It starts with an empirical science, but it goes to the recent state of data exploration also. We can also think of data science as a research method. Taking some problem, we are going to check what happened, how it happened, what will happen, etc. So for that, we can think of various tools, methods that can be applied to healthcare domain, banking. Say, for example, in banking, customer segmentation, we can think of healthcare to check whether this particular disease or kind of issues will spread. These kind of things can be analyzed, no doubt in social network also. This is as a research method. But now data science prominently, we focus like a kind of a discipline, a program. It starts with um, UG, PG certification courses and departments. Great. So the initiative for bringing a lot of things for this has gone to a better level. There comes a kind of question whether it is interdisciplinary or multidisciplinary. These things have to be verified. Like your research, you can also think of that as a workflow. Any kind of activity, whether it is a scientific activity or business activity, we have some kind of formalities to make this as a cycle, a process, an iterative workflow for getting the value and data driven actions from the data as a workflow. Like our program, or as I told, um, like as a discipline, following this, we can also think of this as a profession. As you see that data science is the high ranking professional with training and curiosity to make discoveries with the presence of big data. Actually, they analyze data in different forms. That's why he has given swimming data. Swimming in data can be possible with respect to data science. And other than IT and tech, we can see that the importance of data science is seen in various domains like finance, industry, healthcare, defense, energy, etc. When I was talking to my friend, he was telling that people for energy analytics is the current requirement. So I was really wondering to know about what is energy analytics. So actually the domain is based on energy and environment where they applied this data science kind of things. So a combination of a different discipline with our normal routines coming to a new direction called energy analytics engineer. So data science as a big profession, it is claimed. Now combining all these things, whether it is a research paradigm or it is a science kind of thing or it is a program, whether it is for student or professional, this diagram I found somewhat better for easy understanding thanks to data flare. So what happens here is they have defined this as a kind of Venn diagram where we broadly link domain knowledge, computer science, maths and statistics aptitude. Note that without domain knowledge, nothing will move. This is one of the often I used to stress this. Many of you will agree. We are all good in our activities, programming, development, products development, etc. But still we are searching for domain. Whereas if you take a mechanical engineer or an electrical engineer, they are in their domain and they come to this analytics or a kind of science or whatever it may be, well utilize this for upgrading their domain. Whatever it may be, when we are trying to become part of this data science world, domain knowledge is important. If you do something in NLP or if you do something in crime related, security related, or something related to healthcare, that domain is very, very much important.
Excuse me,
Now
sir.
you can see that. Yes, please.
Sir, you are presenting, sir. The slide is not
Yeah.
moving.
Oh.
Sir, I think you can put it in the slideshow, sir.
Yes, I will. Actually, I have come to some 7 or 8 slides.
Now only we are able to see that, sir.
Oh, wait. This slide is okay.
And now in the first slide, sir.
Now I am in data science. What it is?
No, sir. First slide. You are in the first slide. Now it is in the second slide. Data science, what it is.
Okay, can I do like?
Definitely.
Yeah, I did that only, but it is not. I ran it. Is it coming now?
No, sir.
Okay. Okay, I will do like this.
Okay, sir.
I will move like this. Is it moving?
Yes, sir. It's moving, sir.
Oh, I have crossed around 7 to 8 slides. Anyhow,
Okay, sir.
this is what I was starting like. In normal definitions, we can give simple sentences to tell what is data science. But to understand the evolution of the definition itself, the evolution for the definition, we should start with Kepler's activities, where we have seen that he has involved a lot of data related to planets, very big data. And in that case, a kind of curiosity comes whether Kepler is the first data scientist or his friend Tycho Brahe is the data scientist, or his source Copernicus. Now we can define various paradigms, like in terms of research paradigm, as mentioned, empirical science, theoretical, computational, data exploration. Like that, 4 different paradigms have been seen in the literature. Empirical science more towards uh, very old, even now it is coming under qualitative research, where, for example, study about humans, migration, birds pattern, or why a particular uh, uh, region people are behaving in a particular manner. So these kind of things are empirical science. The next comes with respect to defining some models. As I told, thanks to medical and socio as well as humanity science, such kind of people involved in defining models based on statistics. From third one onwards, our definition of data science is better received in terms of computational paradigm, where we involve algorithms and computers. And in fourth, we can see the current way of doing things in data science. So we can think of data science as a kind of research project, or as a discipline at various levels, UG or PG or certification, anything, or as a kind of workflow. By workflow, what I mean is it can be for a crime branch, or it can be for a bioinformatics branch, whatever it may be, and as a kind of fascination towards profession. This comes as the top. But putting all these things aside, um, this seems to be better uh, given as a Venn diagram. As I mentioned, without domain knowledge, nothing can happen. With computer science and mathematical statistical tools, we are going to analyze, interpret, explore more on the domain. Let us think of some applications. There are n number of applications, as you all aware. Uh, you can see that just 1 second. There is a kind of small this thing. Yeah. If you take any search, from normal text search to any image search, it involves data science. Whether it can be for digital marketing, or it is for product recommendation, or it is for identifying patterns of moving objects. So we can see that varieties of uh, applications are involving data science. The real effect of data science can be seen if we involve big data. Is it visible?
Yes, sir.
Now I am in data science workflow.
Yes, sir.
Um, so I found many interesting articles on data science, but I found this by Philippe Gouveau, a scientist. very interesting. Few slides on his experience about the data science workflow. This is a normal thing only, but in his way, how it comes, let us see. So the process involves acquiring the data, that is preparation, analysis, reflection, and dissemination. These four can be macro level aspects of data science workflow. In the preparation phase, the data scientist or the programmer must first acquire data, reformat it to a form which is suitable for computation. This itself is a very great activity in a data science life. The data, where from it is acquired? This is another question. So days have gone using with the simple data, as all of you know that the world is moving towards terabytes, from terabytes to petabytes, zettabytes, like that. So the sources are different, multi-formatted, multi-sources. So we can see that data can be online repositories, we can download. It can be streaming of applications, a video conferencing application, or a kind of a stock exchange data, or it can be periodically generated from various equipments, whether a space station or weather forecasting station, transport related. Periodically data will be coming, or it can be a kind of logs in Amazon, or a kind of uh, any activity done with respect to a portal, or it can be even a manually entered data. So data can come from different sources, different formats. That itself is again a big exploration before we come to the field of data science. And here comes the danger of getting whatever we see. Whatever we see, whatever we get, if we directly use, the results are going to be maybe correct also, maybe the other side. Provenance is a very important thing. That's what I am telling. This study of provenance itself is a great activity. Whatever data I get in a particular scenario, is it true? I'm not talking in sense of security. Whether it is affected by any noise or anything else, are we getting the correct data? So this reacquisition may be taken care. Sometimes um, we'll be getting very unupdated, non-updated data only. So it is the duty of every portal to update the data so that data science applications will be strong. Um, Data scientists, not only data scientists, but most of us also, we have a problem. Of course, this is a diversion, this slide, but very important to know this. Naming is given for so many things in our activities. A file name or a package name, a class name. Identifying the exact names is a very difficult process. That itself needs some assistance. Even in our, see now also, uh, sometime back, I was told RMKCET 2 to 3 versions of this presentation. And before I started, I was seeing the old version. So naming convention is very important, and more than that, properly applying that file in the context is very much important. Though this is a diversion, I wanted to highlight that. where this data will get stored. So we have moved from SQL to NoSQL kind of things to uh, very recent things like data lakes and data marts. So when we are going to do this data science project or application, storage becomes an important aspect. Moving from traditional table kind of things to new things are required. It can go to data centers also. As mentioned in the first part of this process, raw data cannot be directly used. Say, for example, if it is an NLP activity and we want to check a kind of what he has spoken belongs to a particular language, syntactically or semantically, what he is trying to tell. Suppose we are trying to analyze a kind of audio text. Somebody has spoken something, and we want to check syntactically which language he is talking and semantically what he is talking. Suppose there is a project, the data cannot be exactly taken. Some kind of cleaning has to be done. Normalization has to be done, not only for language related thing, but also for every kind of thing, whether it is banking, security, etc., etc. After getting the data, after cleaning the data, the next step is data may be available in different forms. One in XML, another in CSV, another through mails. That's what we told, that the sources of data is in different formats. But when it is getting to a pipeline, everything should be integrated properly. Wherever required, they should be integrated properly. This is another important thing. Again, if a wrongly interpreted data is given to the pipeline, everything will go wrong. Analysis phase and rest of the phases are traditional activities of any data science project. Just for namesake, I am touching these two or three slides. We have to write scripts, we have to write programs for achieving our activities. So you can see a kind of interesting fact here. Days have gone. Instead of depending only on one particular language or one or two languages, now things have moved to basket of languages, client side, server side, APIs, tools, many things you can choose at your wish. Not only at your wish, but to optimize also. Plenty of options are available. I am showing the analysis phase slide. Is it visible?
Yes, sir. It's visible, sir. Yes, sir, it's visible.
I am showing. Am I audible?
Yes,
Yes,
sir.
sir, you are audible, sir.
Yes. Yeah. So the analysis phase, what I told, like you have to write scripts, edit the scripts, execute, get the outputs, debug. It is a traditional uh, programming activity in a different flavor. That's all. Many times we have to do the management of file and metadata, then reflection phase. In fact, it is a kind of spiral activity. As you know, in software engineering, we have something called spiral model. We cannot think of going at a stretch. Sometimes we have to go back, reverse, revise. So data scientists frequently alternate between analysis and reflection phase when they work. Finally, they do some kind of taking notes, conduct meetings to analyze, make comparisons. If expectations are not met, alternates, etc. This slide I wanted to give specifically because this only gives link to our second part of our discussion. Both in the data acquisition part and more in the analysis part, things are happening in trial and error way. This is one of the serious issues in every project, no doubt in data science projects also. Once a graph comes or a chart comes by showing a result, see, many times the graphs are drawn not for our satisfaction. The graphs are drawn to check whether I am better than the other person. That is the wrong thing. He has achieved 78%. I am achieving 81.1%, and I am happy. There comes all issues. So in that case, for a particular scenario, say social network analysis research, this person is discussing that he has taken different data sets, different experiments, and he was not satisfied. He applied multi-level research to, what is it? Understand the flow of data, correctness of data. So this is a very good example I found. That's why I'm giving here. So what this conveys to us as a student or as a researcher, we should not stop with simple experiments for a better or a smaller way of comparison. But you will ask, when I have to stop my iteration? Of course, we have to stop the iterations, but we should have the ability to question ourselves, to verify our process at different scenarios. That is going to be seen in our third part. So that's why I wanted to give this. So I am here giving one important point here for both the student or researcher point of view, as most of you may be aware. Just I am adding. We all have a notion that for any activity, graph is the ultimate. I have experimented with data and tabulated the data, experimented, then plotted the curves. Fine, good. But the real research comes only from others' graph. Only from others' graph, my graph will come. By graph, what I mean is the chart. A chart or a histogram or a kind of visual representation given by others' work should be the input for doing my work. Our motivation should be from not only from literature statements, but from graphs. That will help us to dig or explore more in our work. So as the formality for data science, dissemination phase is the launching phase, starting from data acquisition and further programming, etc., etc. As a complete product, currently I am giving to that manager or to the community, etc. But is it over? No. Rather, now only things start on the first heading, what and why of data interpretation in general as well as in data science applications. So the first part tried to convey certain things like there are two things coming. For us, it looks data science is new. No, it is already existing, but it is gone to a kind of evolutionary phase. Credit goes to all earlier people we have tried to improvise the concept of data science. When we observe the data science workflow, we found that data is important, at the same time it is disturbing, it is unreliable. So care must be taken to data. So this is the first part. Now we go to the second part, where our real presentation or activity has to start. According to one, it is pretty old because 5 years gone. Let us take that. Though it is 5 years old, maybe only little bit could have been improved. According to this statistics, more number of projects are started in data science. You see, I'm just giving a small lighter side of example. In one busy street, one shop introduced a computer for billing. See, everybody went for that shop because of that curiosity to know. They are giving bills through computers. But within a month, every shop in that street started getting computers and billing. It has become very common activity. So, whenever a new buzzword like big data, earlier data mining, data science, or IoT, blockchain, all this come, we all run behind that very fastly. A very strange marathon will happen whenever a new term is coming to the system. But further hops or further proceedings becomes a kind of questionable activities. If we say the projects completed with success or with value, some value you should give to the receiving domain. So in that case, very few are only completed and not completed due to several reasons. That itself is a research. Why projects fail? Don't bother about data science projects. Why projects fail? It itself is a kind of qualitative quantitative research. How it is quantitative research? By having lot of data related to what is that? Projects, what type of projects, etc. How it is qualitative? Somebody will tell, see, my working environment, I am having very poor computer. Even a PowerPoint slide is also not moving properly when I am uh, discussing with my client. So many issues will be there. So, based on the environment, human factors, qualitative. Based on the available data, quantitative. Of course, this qualitative data also can be converted to quantitative. So, why projects fail is a very great research. It is a what they call it as multimodal research. But according to our discussion, we feel one rat is going on, going here and there. We are not going to kill it, but we are going to as a pet. Without that rat, nothing can ecosystem cannot be defined. So that rat is going to be your data. Data is crucial. It has to be analyzed and interpreted properly. So for this, if I go back to my earlier Venn diagram, if I go to my earlier Venn diagram, I should have brought that Venn diagram here also. Anyhow, sorry for moving earlier. Are you seeing this Venn diagram?
Yes, sir. Yes, sir.
Yes. So according to this uh, Venn diagram, this is not sufficient actually. That's what I am coming here. As such, this Venn diagram is talking about three circles only. prominent circles. But now a new thing based on data is coming. So in that case, some more circles have to be interacted at different levels. I'm again going back to this slide. According to one recent research, one person has worked on Venn diagrams only. How many Venn diagrams are available for data science? 3, 4, 7, etc. He has come out with 14 circles. Not necessarily that all 14 have to be exactly intersecting with each other. He has got PhD on Venn diagram itself. A great person. For his work, his focus was on the importance of what is that? Asking questions. As a project student, as a research student, as a kind of what is that? Professional. The basic thing expected in me is a questioning ability. Sometimes we have to be Socrates. A bearable Socrates kind of nature is expected to grow. Without questions, we cannot move further. So we have to ask questions, why it happened, etc., etc. Don't bother about the diagrams given here and there. There is some meaning in that. Pacific immigration. I am linking to a very old BC kind of thing, activity. Pacific immigration. They started asking a lot of questions. Why people move? Because as you know that migration itself is a great, whether it is animal migration or bird or humans, why they migrate? Question is simple, but to get the answers, even I think 14 circles are not enough. Coming back, we have to analyze, display and interpret. Whatever we told about clip guo, we are making it in a simple form here for this presentation. For any application, break down the data to discover the meaningful units, themes, patterns. Then only you can go further. Provide the visuals, whether connectivities are there or missed. See, there is an interesting recent article. Hope that here and there I will be diverting. Kindly bear. I don't want to go with the just presentation alone. There is a very interesting article, how they linked. It's a very great thing. One industry has been doing machine learning applications continuously. One of the engineers, he was not satisfied just by getting the salary after the projects. He was more curious to explore further, and he found that a drastic, rather shocking thing. Around 70% of the things what they are given to outside world have errors. Now we have to rectify, and for that he has used Neo4j. Neo4j is a tool. It is a social networking kind of tool. By applying social networking tool in such machine learning application, he found better results are coming. So how he could get that? By seeing the displays of the earlier activities, he found some missing things, and that he could improvise through a kind of social network software. Of course, we have to interpret. So analyze, display and interpret. So first thing, analysis. That's what we have already told. I am not bothering about analysis now. Hereafter we are going to see data interpretation. Now I am in my second part. We have understood what is data science. Various Venn diagrams are possible. Now we are given some activity where data is involved. What kind of interpretation is possible? As a worker, a student, professional, he may deal with many things. A qualitative person will bother about text, visual, or oral data. Quantitative researcher will be bothering about numbers, charts, graphs, as well as statistics. Say, many times, even academic people, we are supposed to, we are doing that in the name of NBA or NAC or kind of things. It's a good activity where a lot of such questionable kind of things are there. What is the program outcome? What is the course outcome? If I am giving a person S grade for a particular subject, is it correct? If I am giving a very lower grade for a particular person, why? So these kind of analysis are done at a greater level under the headings of educational data mining as well as learning analytics as well as learning data science. So both quantitative as well as qualitative data interpretation are expected. What is quantitative way of doing things? Testing the hypothesis, which are expressed in numbers. We have to check with a larger sample size to POC, that is proof of concept, mainly involving maths and statistics. In case of qualitative research or qualitative data interpretation kind of things, we formulate the hypothesis, rather assumption. We express in terms of text, starting from simple sample size, we go to a greater level. Finally, we summarize, categorize, interpret. Now, when we talk about the qualitative data collection, as I mentioned, why projects fail, why people are not buying this product. Many times we do wrong way of qualitative aspect also. I would like to see you in the net a very old story on UPS and FedEx. UPS is United Postal Service and FedEx is another courier service. Before FedEx came, it was only UPS as the prominent postal service in US. But reception from customers came down. They analyzed why people are not coming to UPS. They found that there is a new company called FedEx came somewhere at the end of the street. How they came? How FedEx came when already a giant UPS is there? Because this FedEx group started doing some kind of analysis and data interpretation by asking the people through surveys, interviews, ethnographic studies, are you satisfied with UPS? What kind of services you expect? Whether the customer service is good. So preparing questionnaires, finding the weaknesses. So you can always see that the next great person to come in any field is not only based on his or her talents, but based on the earlier person's limitations or loopholes. If I am also to be one among the lot, I can always show my talent. But when I want to excel, when somebody wants to excel, the first point in the notebook is what is existing, where they fail. So this qualitative research is important. That's what done by FedEx. Of course, the battle between UPS and FedEx, it goes in a kind of very big way. Again, UPS went higher, FedEx down, FedEx up. So many things happen. But it is an interesting story. Now come to quantitative, where we take surveys, experiments, observations, all numbers, all numbers only. Numbers are easy to process, difficult to understand. When we come to this quantitative, there are two types of statistics, credits to statistics and maths, the two pillars of anything. Any data science, the major two pillars are maths and statistics. So what are these two? Come from the right. Is it visible?
Yes, sir. Yes, sir. It is visible, sir.
Starting from descriptive statistics, we have to work with population. We cannot involve entire population, but sample has to be taken care. It covers various methods like mean, etc. And from descriptive, we are going to inferential statistics to infer the unknown parameters of the population from the known ones. We have to arrive at conclusions from the existing data. The diagram tells that from sampling from population to descriptive. The reverse, we can go for inferential statistics. If you take the sub areas of descriptive statistics, we have mean, median, etc. that acts location parameter, standard deviation, variance, etc. as dispersion parameter, frequency tables, graphs. All these things are necessary to do the quantitative aspect of your work. In this regard, as all aware, there is something called noir. Data can be defined as noir in your system, N-O-I-R, or it can be a reno, any name you can give. What is N? N is nominal, O for ordinal, I for interval, and R for range. If you are involving something like states of a country or the mobile numbers of a class, mobile numbers of an organization, they're all nominal. Anything that ranges from 1 to 5 ratings, rating for a product or a survey, that is ordinal. We can also think of IQ level of a student, interval, our grade scores, and ratios. When we talk about CO2 emission or living space with respect to geography, all these things we can think of a ratio scales being defined. So you can see that your data coming to your data science projects will be one or more combinations of N, O, I, R only. Next, as I already mentioned, questions are important. But for which question, which kind of statistical tools or what kind of data being involved, that should be taken care importantly. Say, for example, we have a question. Do you want the proportion of people who answered in a certain way? We have conducted a test. We want to know how the proportion of people answered in a particular way. Maybe to verify whether they have copied or they have taken from same source some activity. For that one particular type of tool, we want to see the answers or scores or something with respect to, say, if you take IPL, you can see all these kinds of questions. If you observe, I am telling in a very lighter sense, if you observe the questions asked to at the end or uh, during the commentary, some people will be posting queries. You can very well see that the data required for those questions will come under any one of these things. They may expect a frequency. They will ask, who is the player who has continuously taken 50s in a particular ground? See, this question itself is a very interesting one. Then only the process. Many times the inferential statistics we take about the population, uh, because what is it, involving the entire population is very difficult. Only samples have to be taken, but that itself becomes a problem. I am slightly linking this to some of the image processing applications done. The failure of some of the image processing applications, they have taken samples at some random locations of a particular species or something like that, and their aim was to compare the earlier work, their results as better than that percentage, everything over. But they have failed to observe that in some part of that specimen, some drastic variations are there. So samples have to be taken from different locations of a space. That's why I'm stressing that doing research is secondary. Doing experiments, repeated experiments, and what is that? Different types of experiments are important. Using a sample with smaller size, dangerous. But you are supported by various ANOVA, correlation, testing, etc., etc. In a nutshell, is the study is about qualitative, sorry, if the study is about quantitative based on normal, ordinal, interval, or ratio, you have different people coming to help you. Frequency, range, mean, mode, so many people will come. If it is quantitative, if it is qualitative, these kind of things have to be done. If it is qualitative, I don't want to um, explore more on this, but have a look on this. Whenever we are having qualitative, as an example, I am telling about only one thing. A grounded theory approach is used in software engineering research to check how the projects are functioning, sustaining. Apart from data-based activities, they have also used grounded theory, a quantitative approach. So you can see that we have content analysis, narrative, discourse, etc., etc. And for each one of them, we have got plenty of uh, evidences to say that they're all useful for doing qualitative activities. Now again we go back to quantitative. This is my third part. So in the second part, we focused on what is meant by interpretation. There are two aspects of research or work to be considered. One is quantitative, another one is qualitative. And for each one of them, plenty of methods are there to help you to arrive at a particular platform and proceed. Giving importance to data interpretation. This is about second part. Now the third part is about a particular situation. These four things are common to any kind of data science project. Whether it is a new search engine to be developed, or a machine translation, or it is about IoT application, or it is about a kind of customer segmentation, whatever it may be. First, draft the questions, get the data, cross tabulate, filter. Second part is very important. Then, as usual, crunch the numbers. So, out of these four things, our focus for this third part will be cross tabulate and refine the results. Let us think of a small example. Assume that maybe nowadays it is there in few institutions. Earlier we used to have some kind of academic tours. Academic tours, whether it is college side or school side, is a kind of exposure for students, sometimes faculty also, to know what's happening in the outside world. Of course, thanks to project phase, where people go to, as well as interns. Intern is very much important. Internship, where they come to know about various things in the industry. Let us assume a scenario where in a particular institute, a group of students with a few non-teaching, that is technical people, as well as few faculty members are going for a particular place to see the plant or to see the equipments installed, etc. etc. Now, we are bothering about a question. The administrator wants to know about something. What is about your trip for this particular place? It doesn't stop with that. A beautiful question like, will you come next year also? See, that question is very important. Simply instead of asking what is your whether lunch is good, whether climate is good, what you understood, they're all different. Whether you will prefer touring like this next year also, that is a very tricky question. Do you wish to participate a similar one next year also? This is the question asked to the candidates. They got some responses like raising the hands or writing simple sheets kind of things. 71 percentages they told yes, 18% no. Some good people told not sure. Very safely they were told not sure. Can we take this data as the success or the expectation of our program? No. This is a wrong conclusion because of the wrong data collection. So that's what people often suggest, cross tabulate. Within a group, find subgroups. instead of asking, suppose there are 50 participants or 100 participants, students, faculty, supporting people or technical people, cross tabulate, define subgroups. How many faculty want to come? How many students want to come? How many people in technical people want to come? Why? So cross tabulation is very much important, and we have a lot of tools for that also. This is going to help you to filter so that you can further model the data. Filtering means narrowing your focus to a particular subgroup. You can ask questions. Say, for example, some students from a particular branch, they are telling no. You see, as a computer science student, if I am asked to go to a chemical plant, I may not be interested. I want only immediate job. I don't want to visit any place. This is the reality. Why they don't like this? So can we improve anything? Can we think of uh, conducting a tour where 3 or 4 locations can be visited? Better decisions can be thought of. For this slice and dice, you see, in warehouse we had a wonderful operation called slice and dice. Same thing here will come under cross tabulation. Now another worry is coming. Overall, how much satisfied with this trip? 75% tell that we are satisfied. Out of what? That is population comes into picture. Population sample, just 10 people only we are asking, and out of 10, actually 100 people have attended, but 10 people only we are asking, and all 10 tell yes. 10% only. It is a wrong conclusion. I am skipping because we have few more slides. Here people expect you to focus on the trust value or confidence level. Based on statistical significance, we have to do the process. You just focus this point. Drawing an inference based on results which are inaccurate is faulty. Only 10% asked, all okay. That we cannot claim as success of the work, because sample size matters. That's what I told. There are wonderful tools for this thing. In the industry, we have high-end. They have high-end tools, including Six Sigma, etc., factor to be taken care. But from this slide, what we infer or what we get as a takeaway is that sample size is important, and that should be checked with many places. Now we can also think of introducing new features so that your survey will become a better one. Instead of asking plain question, how many will come next year? How many like this? You introduce some more factors. See, actually, 3 days trip, we had a invited thing, and we have some kind of demos. We had some kind of presentations by industry people. At the end of the day, students giving their feedback, lunch, some sightseeing places. Like that, you divide the entire process into various sublevels, and for each one of them, you ask the value. Now you can see that A slight variation is happening. So what they tell is, don't depend on a particular question or particular attribute. Focus on different attributes. This is what people call as feature engineering. As data scientists are getting popularity, feature engineering also is becoming prominent. Exploring features will come by questions. Suppose you are having 10 sessions. Suppose 100 people saying they attended one session, 50 people 4 sessions, 100 people 5 sessions. Suddenly a lot of variance will be there. How to manage this variance? Finally, we will get a very sad figure that the activity was not that much expected. Somebody may tell, sir, this city that you have chosen is a very wrong place. We have gone at a wrong time. So, not only based on this kind of, you see, as we saw here, like 1, 2, 3, 10 corresponding different activities, sometimes you have to get views from text based also. In a larger context, getting opinions and analyzing that or mining it, that will always help you to get more inferences. It may be wrong choice of the timings or city, rather climatic condition also. Now, another interesting thing in the same comes, very important thing. Analysts say that one of the serious issue caused in most of the projects, big data as well as data mining, now in data science projects that is continuing, is causation. What is causation? That is different from correlation. Many times causation is considered as correlation in most of our works, leading to wrong results. Causation is one factor resulting another. Correlation is when two variables move together, one may or may not influence the other. They are independent. For example, we have taken people to that picnic spot, rather industrial visit. We observe that they are drinking hot chocolate and they are also wearing mittens, that is gloves. As an analyst, can I come to a conclusion that whoever wears mitten will take hot chocolates, they will drink hot chocolates? And if I take this into consideration, that is a wrong process, that is, it is causation. That's what given. Cold weather is the independent variable and hot chocolate consumption and likelihood of wearing mitten are dependent variables. One is causation between others and other is correlation. We have to do regression analysis also. As you know that whether it is machine learning you call or data mining you call or data science technique we call, strictly speaking, correlation and regression, they belong to statistics only. It is wearing a new dress of data science. That's all. This discussion goes like that. I would like to, um, introduce one more thing here, like maybe if there is a question, accommodation, and everybody has ticked accommodation is good, and because of that we have got 10% result. Now the management has to consider in a different way. We expected this tour program for getting some educational content and some kind of knowledge enhancement. But people, instead of giving values for other things, they have given value for afternoon lunch. They have given full marks for that. Sorry for diverting you with a small uh, deviation I am telling. One social service person wanted to promote his ideas. He wanted more people to attend his events. Am I audible?
Yes,
Yes,
sir.
sir. You are audible, sir.
Yes. Kindly don't think that it has gone to a kind of uh, just for a lighter side. One social service person wanted to uh, invite more people for his events. So he started conducting events at different places. At the same time, he told his office people to arrange for some kind of snacks in between. So now uh, he started conducting events region wise, zone wise, national wise. After 6 months, he wanted to uh, know what is the status of this event success. Curiosity kills cat. So what happened? He asked a question and expected every participant to respond. Kindly give your name, when you attended, what you like. Almost out of 1,000 participants attended in different places, 900 people responded, and he started seeing the response. One person is telling, "Sir, your discourse or event conducted in Coimbatore was very nice, but the only thing is, instead of sabji, you could have added something else." In Pune, somebody else was telling, "You could have added some juice also." So now the inference is not the success of the event or the knowledge dissemination, but need for changing the snacks menu. This what happens with respect to causation. Correlation is important. That's why I am diverting that. As you know that correlation and regression are playing a very heavy role. Uh, they cannot be. I am finding recently for the past 3 4 years, researchers are not using. They have gone to various models, neural network models. Good, neural network models are good, but again, the strength of a product or a project is based on your correlation and regression. There's another interesting I would like to share, a fan demand index, a botheration by a games committee after this COVID-19, whether people will come as they used to come. So for that, they have developed a package during COVID. You see, during COVID, we had a lot of losses. At some time, some good things also have happened. So in that case, this project is a data science project that aims at, will the fans come to the games next year also? Will they be interested? More number of people will be coming. What may be the new locations? All these things were analyzed and predicted. They have used predictive analytics for this. Now this is my fourth part, closer to the nearing closer or closing session. Some more slides are there, but I will make them faster. As I told, our student life, researcher life, or professional life starts from a visual and end in a visual. Lot of tools are available, plotting, charting, etc., etc. But which chart or which thing to be taken care for what is a big question mark. See, if you go to R programming or Python, that will always do it sincerely. R and Python are very sincere tools, but the result of the tool depends on a good master. Who is that? We. So in that case, we have plenty of options, but choosing correct thing for correct activity is very much important. If you want to show the rate of change, sudden drop of temperature, go for chart. We can go for histograms for distribution and relationships of single variable over set of categories. Line charts are useful at some contexts when you have continuous data. Timeline charts when values range over a period of time, say your health related thing, or it is a stock market thing, traffic, etc. Scatter charts, relation between two different variables, especially for correlation related things. So, as all of you know that different charts are already available, but choosing the correct chart based on the data interpretation is important. Rather, this will help you to interpret the data also. It is a cyclic process. Multi-axis charts. So several tools are available in the market. That is not a great issue, but choosing the appropriate tool and why we choose that chart, particular chart, is important. Sometimes improper visuals, wrong interpretations. See, if you see the left corner, a chart is prepared, but what is that? Nothing is inferred from that, but it is a chart. It should not only help me, but also for the next person to take the research. This is another chart where for human this thing health related kind of thing, a chart is drawn. From this also not much can be given or inferred. So the purpose of charting is to infer, project. Continuing this line, that is in this fourth part. First part on data science basics, second part on data interpretation, third part on something related to a case study or a kind of an academic tool, how the data is interpreted, etc. And fourth one is on visuals. Continuing that, bias. Bias is one of the dangerous thing. It may come from various sources. As people say that around 70% of the human population are biased towards something. In their daily life, they are always biased. Whether I am in a shop or in a traffic or in a kind of working environment, whatever it may be, in society, 70% of the people are highly biased only. They can come from different reasons. So care must be taken on bias, phrase usage bias, question order bias. So many bias are there. So I'm not going to the, because much work is done by psychology people only on this domain. Bias related activities are done by psychology people. So that's why I am telling that data science Venn diagram, as of now, it is 14 circles. One circle completely psychology. With this, I conclude. So let us focus on certain important things as a data science projects where data interpretation plays a key role that is important. Said many times Simpson's paradox may come into picture. That's what we saw in the academic tour example. Say in a company, overall wages we are showing that raised, but within the group, fallen. The class performance is good. This is the class where many toppers are there. But do we have any lower ranked people also? That should be the that should be the consideration. Many times we should not work for specific spaces. More specific spaces to be taken care, leading to genericity. That's what I'm repeating. It is Google, I think, it is Google who has stopped some of the image processing applications by wrongly applying dimensionality reduction techniques. Any good thing may also have, if you look the other side, unwanted effect also. Dimensionality reduction techniques are wonderful techniques in any data processing, but when they wanted to bring uh, this kind of photo identification, image identification, or moving object identification, they found that it has given some ill effects also. When they bring to genericity, fail. Many times, statistically significant things may look different in reality. No doubt, scalability issue. I have talked a very, very simple, trivial example of academic tour where 100 students, sorry, 100 participants. That is a specific case. If you take a big organization or a country or an employee satisfaction, it is a big data. So, infrastructure change, process change, volume change, etc. etc. Next point, already told, causation and correlation should be carefully taken care. Sixth point, similar to earlier point only, but e-commerce people worry heavily. It was highlighted by Amazon research. Bounce rate. Percentage of visitors who navigate away from a site after viewing only one page. This is a very dangerous issue. Of course, we cannot spend time also. The last one I wanted to stress, very wonderful thing that involved quantitative as well as qualitative kind of data interpretation that happened in 2020. Mar, it's a lady, an aerosol scientist at Virginia Tech, who is a mix of 3 or 4 domains. Again, go to the Venn diagram. According to her, 4 to 5 Venn diagrams are ticked. She is a domain expert, cross domains. She is a data scientist, statistician, etc. etc. She is also a kind of social science researcher. So, what happened? How the virus is spreading? That was the research. The conclusion by majority of the people accepted by who was droplets, not by aerosols. So debate, fights, discussions. Marr was going on telling it is not only due to droplets, it is also due to aerosol. Nobody accepted. Battle went. But who analyzed, interpreted the data in parallel, silently, and announced on 30/20/20? Actually, this war started from uh, that 19 end itself. She has started around 19 December, January 1st itself. But by April, who has accepted that it is spreading because of aerosols as well as droplets. So even a great researcher or great organization may fail if data is not interpreted properly, the sources are not interpreted properly, not analyzed properly. So this is the conclusion from my side. So data science is important. Data is very, very important. But analysis and interpretation is very, very important. And any analysis and interpretation is context based and time bound only. So with that, I conclude my presentation.
Thank you, sir. Josephine ma'am, whether there is any questions in the chat, madam, YouTube chat.
YouTube chat, there is no questions, but they have given one question, ma'am.
Yes, you can read out that question, ma'am. So sir will take up.
Yeah. Student has asked that is quantitative research as reputable as quantitative research, like that she has asked.
Yeah, please.
Yeah, is quantitative research as reputable as quantitative research?
Yeah, very good question. Good question, actually. Now people have gone to quantitative research. More in number, quantitative research is being carried out. But when we talk about research, it started only with the qualitative aspect. Starting from Copernicus or whatever we told that Kepler. Most of the research activities were qualitative only. But once computers and algorithms came into picture, where things can be simplified, people started moving to quantitative research. But what people tell is that it is better to go for mixed mode research, both quality as well as quantity. See, for example, let us take one small example. whatever research we do or activity we do, it should be useful for the society. Say one important research, why people in a class, some people are not able to perform well. We can always get a lot of data and we can tabulate, we can do charts, data mining, or cloud can be used, everything can be done. But many of us, we are not bothering about the performance of a student belongs to the background, economic condition, the geography where they live, and support what he or she has to get, and what kind of inputs, further inputs we can give, because all these things are coming under qualitative features. They are not considered into our quantitative process. That's why people suggest that for going for a better results, mix these two, qualitative as well as quantitative.
Thank you, sir. So there is one more question in the chat box, sir.
Yes.
One of the student, Nitosh Balaji, has asked that what is the best way to do data interpretation? Is asked. So can you hear me?
Best way to data interpretation.
Yes, sir.
Thing is that first we should get the data and we should analyze, from where it has come, including the source and the type of data, and then as mentioned earlier, whether it is belong to nominal, interval, range kind of thing, that is Neuer kind of data, we should apply the proper technique to interpret the data. See, why and how are important in the earlier stage. Why and how. Instead of what has happened, we should be bothering about why it happened, how it happened. These two are important for data interpretation.
So one more question, sir, from Sanjay. What are the limitations or potential sources of error in the data collection or analysis? Yes.
Yeah,
Could you please answer?
yeah, it's a good question. More technical kind of thing. Errors may come in different possible ways. See, whenever we, again, data source plays a vital role. See, many times, even in our research, I am telling in a casual way, we are normally taking somebody else's paper. There, we are first searching for whether he has given any scope for improvement. If you see any literature survey, as a researcher, my first botheration will be whether this person has given any line, this research limitations. From that, whether I can do the research. This thought only is there. But what we have to do is, we should get the data also. This becomes a bottleneck. Most of the times, the data sets used by the source paper, they are not revealed. There itself, some 20% block is there. Just by some literal sentences, by taking some Kaggle data set or some movie lens data set, I have worked. Have we ever worried about the what is that provenance of Kaggle dataset? That's why this qualitative research people will tell the best research will be only with respect to a particular domain. See, I will tell like this. My Australian friend used to tell, first write a sentence for your research. The behavior of mobile users. The behavior of mobile users. Let this be a title. But this is a very general title. Behavior of Trichy based mobile users. That's good. The behavior of Trichy based mobile users belong to student community. See, now you are narrowing down. By narrowing down, you can always get better data, and that leads to better data interpretation. You understand what I told?
Yes, sir.
Again, here also that behavior, what kind of behavior? What kind of behavior to be narrowed down? What kind of people to be narrowed down? These two things are important so that we will get the correct data.
Sir, there is a few more questions, sir.
Okay.
One is from Srinath Young. He has asked that how do data scientists determine the reliability and quality of the data they are interpreting? Yes,
Reliability and quality of
data they are interpreting.
that's what you see. The source is important. When we talk about the source, another one person is waiting for coming in the discussion. In our discussion, I have suppressed that person. That is nothing but security. Let us make that person away. Assuming the data coming is coming from a correct source, noise may be there. Noise may come in different possibilities. The structuring of the data may not be proper. Only these things will ensure the validity of your work. And if they are valid, automatically things will be reliable.
Sir, one more question, sir.
Yes, yes, yes.
Yeah, Sanjay has asked whether this quantitative or qualitative analysis, as you said earlier, depends on our goal also is one more thing, sir.
Yeah, that's good. That's good. Actually, currently, most of our goals are towards quantitative research only. We are not bothered for qualitative. The
Yes, sir.
fear, the fear of getting the data, or fear of the time needed for doing the work. Even with quantitative data, the time we are unable to spend as expected. See, already we have got a lot of Kaggle data and other data. We are unable to experiment and get the results.
Yes, sir.
If you involve qualitative also, time consumption will be more, and people are not ready to focus on that direction.
Yes, sir. I think a few more questions are there, which we will be sending to you so that you can make it posted to our group.
Certainly, madam.
As time is going to be a constraint, just we have it. Ma'am,
Yes.
you.
Thank you, sir, for taking the time to share your insights and expertise with us today. Your contribution is truly valuable and will have a lasting impact to this, sir. All good things come to an end, and it's a duty to be grateful for what we have. Now, I call upon Dr. Valamadi, Professor and Head of Department of Computer Science, who inspires her team to work towards common goal to deliver the vote of thanks. Please, ma'am.
I am interrupting before the next person.
Yes.
So I have to thank the management and Pratyusha madam for giving this opportunity. And I'm really surprised that during Sunday also people are hearing about that too data science, that too things like quantitative, qualitative research. That's a great thing. So that shows the commitment and the greatness of this institution. Thanks to head of the department and other stakeholders for initiating this kind of activities. Thanks to the participants. Thank you. Thank you.
Thank you, sir.
Thank you.
Ma'am, Malarmati ma'am.
Yeah, is it audible?
Yes, ma'am.
Good afternoon to the respected chief guest, respected principal, faculty members, and my dear students. Good afternoon once again. I have immense pleasure to deliver vote of thanks on this occasion. I would like to thank our honorable chairman, sir, respected vice chairman, sir, for the support and approval to conduct this Tech Talk program. On behalf of our management, principal, dean, Department of CSC and Artificial Intelligence and Data Science, my heartfelt thanks to our guest speaker, Dr. S.R. Balasundaram, sir, Professor, Department of Computer Applications, NIT Trichy, for accepting our invitation and being here with us. Sir, today we had the opportunity to hear your enlightening speech on data interpretation in data science applications, and this will be going to help us to do research in data science. Thank you so much, sir. Special thanks to our principal, sir, Dr. K. Ramar, for his constant support and guidance to motivate to all the aspects. Thank you so much, sir. I would like to thank Dr. R. Pradikshalaxmi Madam, Head of the Department of Artificial Intelligence and Data Science, to coordinate this event successfully. Thank you, Madam. I thank Dr. N.R. Reginpal, Dr. G. Vasudevi, Dr. V. Vijay Rajan, Josephine Samila Madam for the support throughout the program. Thank you, sir and Madam. I thank everyone who had helped us to make this event a success. Thank you. Big thanks to the faculty and the students for the active participation in this program. I request you all to kindly share whatever you have learned today to your friends. Thank you so much for the opportunity. Have a great day. Thank you.
Thank you.
Thank you, ma'am. Once again, on behalf of our organizing committee, I thank you all for joining with us today. Thank you, ma'am.
Thank you, sir. Thank you very much.
Thank you. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
Thank you so much, sir, for your enlightening speech. Thank you.
Thank you.
Vijay Raja, sir.
Thank you, sir. Thank you, madam.
Thank you, sir. Thank you, sir.
Sir, thank you, sir. Principal, sir. Thank you, sir.
Thank you, Principal, sir. Thank you.
Thank you, madam.
End பண்ணிடலாமா, sir?